Hello, today we're here to talk about the 6 simple machines in physics. There's 2 main types, the inclined plane and the lever, but from those 2 main types, we also get a few more. From the inclined plane, we also get a wedge and a screw, and from the lever, we also get a pulley and a wheel and axle. So let's go through these, look at some real-world examples, and discover why we use them. First up is the lever. A lever is a solid bar that rotates around on a fixed point. That fixed point is called a fulcrum. And there are 3 different types of levers. So let's look at them one at a time. First, let's look at the first class lever. Now this one, you have the fulcrum in the center. It's where you pivot. And you have the effort on one side, and you have the load on another side. If effort goes down, the load goes up, and vice versa. This is the simple first class lever. Effort is on one side, what you put in, and the load, or what you're trying to lift, is on the other side. A good example of this type of lever is scissors. With scissors, you have the fulcrum in the center, the pivot point. You have the handles on one side, where you apply your force, and you have the thing that you're doing on the other side, the cutting. So scissors are an example of a first-class lever. The second type of lever is a second-class lever. Now, for this one, both the effort and the load are on the same side of the fulcrum, but the effort is further out. So it goes fulcrum on one side, your load or whatever you're trying to lift in the center, and then you add effort to that outside. A good example of this lever is a nutcracker. You have your fulcrum or your pivot point on one side. On the opposite side, you apply your force, so you squeeze together, and then in the center, you crack the nut, or what we call the load. So this is a second class lever. Now a third and final class of lever, again, has effort and load on the same side, but now they're backwards. So again, you have the fulcrum, or pivot point, on one side, but this time you have effort in the center, and on the outside you have the load. An example of this is tweezers or a pair of tongs. You have the fulcrum or the pivot point on the outside. You would squeeze in the center, and on the very edge is where you pick up whatever you're trying to pick up. So these are the 3 types of levers. I know that they can be a little confusing all at once, but once we get to work with them a bit more, you'll see the advantages of each. The second simple machine is a wheel and axle. A wheel and axle is a wheel attached to a shaft. And this is pretty simple. When the axle spins, the wheel spins. Or it can also be the other way around. If the wheel spins, so will the axle. I'm going to give you 2 examples of this. First, let's go with what happens when the wheel spins and then spins the axle. And that's this example down here. Let's say we turn this wheel. Well, as we turn that wheel, the little axle here is also going to rotate around. When it rotates around, it'll coil up the rope and bring up the bucket. So in this case, the wheel turns the shaft. Now let's look at our other example, the bicycle. Well, when you pedal your bike, you are turning an axle. And this axle will turn the axle back here, and that axle will then turn the larger back wheel. So in this example, you turn the axle, and the axle turns the wheel. In class, we'll talk about the advantages of both of those, but for right now, you just need to understand the wheel and axle basic concept. Our third machine is a pulley. Now, you've probably seen pulleys and cranes and all over the place. We define a pulley as a wheel and axle with a grooved rim and rope. You use a pulley by attaching a weight to one side and then adding effort or pulling on the other side. Now, usually you'll see a pulley mixed with other pulleys. Like in an example here, we have 2 pulleys working together, or here we have 3 pulleys working together. Later, we'll talk about why you have multiple pulleys at once, but for right now, just know that a pulley is a wheel and axle with a grooved rim and rope. The inclined plane, our fourth simple machine, is probably the simplest. It's a sloping surface that supports the weight of an object while it changes levels. This is, in simple terms, a ramp. We use it to get from one level up to another level. And you can see this all around in your everyday life. Our fifth simple machine is a wedge. A wedge has a thick end and a thin end, but it can be used for several different things. When you apply the force, the wedge changes the direction of the force and pushes out sideways, which usually increases the force. We can use it to cut, as in a knife. We can use it to split things, as you would with an axe. Or we can use it to hold things together, as you would with a nail. All of these are examples of wedges. Our final simple machine is a screw. A screw is an inclined plane wrapped around a cylinder or a cone, and they have 2 major uses. If they're like the general screw we think about, they're used to hold things together. However, they can also be used to raise or lower objects. Examples of this are in this diagram, where you see the man turning the screw brings the water up and dumps it out up here. This is an example of a screw. Another example of a screw is the little corkscrew spin that a gumball machine sometimes has. When the gumball drops and spins around, this is an example of a screw because it's lowering the object down. So today we've talked about the 6 simple machines. We've talked about levers, wheels and axle, pulleys, inclined planes, wedges, and screws. If you have any questions, please feel free to message me, and know that in class we'll talk about the mechanical advantages of each. Have a good day.